Okay, so we're doing 2.7, the conjugates theorem today. It's not too bad. You have to remember what conjugates are, though. So let me pull up this slide. Go ahead and write down the theorem that you see at the top. I'll go ahead and cover up the bottom. The bottom's going to be fill in the blanks. If you know that a plus bi is one of your solutions to your polynomial, then it's an automatic that a minus bi would also be a solution. And the same thing happens with radicals. If you know a plus radical b is one of your solutions, then you would automatically know that a minus radical b would be another solution. Just go ahead and jot that down. I'll pause the video. All right, so let's go ahead and look at two example problems. These are fill in the blank. If I know that 3 minus 2i is a solution, then who else is also a solution?
3 plus 2i.
Good, and I'm putting them in parentheses because you would end up foiling these later on. You'll see how that works. But if 3 plus radical 2 is a solution, who else would be a solution?
3 minus.
Yep, 3 minus radical 2. So you're going to use these when you have radicals as solutions and when you have imaginaries as solutions, and at no other time. Hello.
These eyes are not exponents, they are
Imaginary unit.
imaginary.
Hey, it's good that he asked that, actually. Spencer, you're such a scholar. Today, if you would see an I squared, we need to review what we would do.
Bigger than I.
We would replace it with
Positive.
-1. So when you see that I squared goes off, I used to like say, whoop, 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 replace it with a -1, because that's what you have to do. I'm worried you forget what I means, Andrew. I means the square root of -1. It's called the imaginary unit. So there's a good review. Chapter 1. Chapter 1 review for you.
Not bad.
It's okay. Chapter 1 was forever ago. All right, so we're going to do a few example problems. Before we start, let's pretend that I told you my polynomial had the solutions of x equals 7 and x equals 2. And I wanted you to tell me what it would look like in factored form. What binomials would go along with these two solutions? I'm pretty sure you know this, yeah?
X minus 2 and x.
Perfect. So this is just a reminder that if they give you a solution, you do x minus that solution as your binomial that you're creating, okay? So let's make it a little bit harder. Let's pretend x equals 3i was a solution that they provided to me. What would be the binomial that would go along with that? X minus 3i. It's always x minus the solution they provided. Now the conjugates theorem would make us go one step further, and it would make us include the conjugate of this binomial. Because the conjugate just says if you have an imaginary solution, the conjugate is also a solution. So you're kind of on your own to remember to include this guy.
So what about if it's x minus 2, would it be x like plus 2?
Nope, because that's a real number. You only do the conjugate theorem for radicals, which are irrational numbers, and imaginary numbers. So you don't need to do the conjugate theorem on the real numbers. Question or no? No. It is. My board doesn't write real well over at the edge, so sorry about that. Oh, back one, sure, here.
So why is it 3R? I thought that's square.
Okay. All right, so we're going to play pretend here, and we're pretending that we solved a polynomial, and we got these three solutions. -5, -1, and 2. Okay? We have to work backwards. We have to write out the binomials that correspond to those solutions, and we actually have to FOIL them out to figure out what that polynomial was in the first place. Isn't this weird? It's backwards from what we've been doing the last week. Instead of finding the solutions, they give you the solutions, and you find the polynomial. Why the funny look? Okay. All right, so x equals -5 is our first solution. What would be the binomial that would correspond to that solution? Lexi? Good. X plus 5. So x plus 5 would have a solution of -5. What about -1? Lexi?
X plus 1.
x plus 1, perfect. And then what about my solution of 2? Spencer?
X minus
Perfect. So everybody agrees that these 3 binomials would yield these 3 results? Okay. So now we're just going to do a foiling extravaganza. And today's just a bunch of foiling, honestly. So just a reminder, you can't do all 3 at one time. You can only do 2 at a time. I would do the 2 positive ones to start. So x times x squared. X times 1, 1x. 5 times x is 5x. And 5 times 1 is 5. Add up your middles.
So do you have, well, did you do the box for
You could have done the box for the first 2. It would have been a 2x2 box.
right?
I normally don't do boxes when it's just 2x2s. I'm absolutely going to do a box now, though, because I have a 3 term times a 2 term, or a trinomial times a binomial. So yeah, just a reminder, if you like rainbows, go for it right now, but I don't like rainbows on a problem this large, so I'm going to be drawing myself a box. Give myself some more workspace. So you want a 3x2 box. We have our x and our negative 2 here. X squared, 6x, and 5 here. And we start filling it in. Anybody want to tell me what all my entries look like? Spencer, what would go here?
X cubed.
Good. What would go here?
X squared.
Okay.
5x.
Perfect.
Negative 2x squared.
Mhm.
Negative 12x.
Yep.
And negative 2.
Perfect. So I'll pause, make sure everybody at their seats agrees. Need rainbows.
Mine just be my rainbows.
All right, well, I like boxes because these 2 and these 2 are my like terms. I can find them very easily. My final answer is x cubed plus 4x squared minus 7x minus 10. Now, how can you check that you didn't make a mistake somewhere along the line? Somewhere along in your foiling journey. Let me click this so you can see the whole problem.
Look at all the answers.
Well, that only checked that one of the answers would work for this one. I was thinking, yeah, go ahead.
You could use synthetic division.
You could, but you'd have to check all 3. That would take forever. Yeah.
Well, simple one, you can put both in your calculator, graph them.
Yeah, I would just stick this one right here in my calculator, graph it, and see if it has these 3 x-intercepts.
Or if they have the same.
Yeah. Well, what do you mean by plug both in? Do you mean plug this one in?
Yeah.
Okay, so he's going to plug this one in and plug this one in and see if they have the same graph. But what if you messed up this? You know what I mean? You need to go back to here when you're checking to make sure your polynomial has these answers. Because what if you made a mistake here? You know? Yeah. So yeah, just graph it and look for the x-intercepts. Make sure they are -5, -1, and 2.
Could you also use long division?
You could use long division. You must like long division. It's not the funnest process in the world. Alright. Okay, this is a good one. There's 3 solutions. We're going to find the polynomial that would have these 3 solutions. Okay, so we have 3 solutions. Let me make my 3 binomials to go along with the 3 solutions. What would the first one look like? Yeah? X plus 3? I agree. What would the second one look like? Yeah? Yeah, x minus 0. So basically x minus 0 you could just write as just x, okay? And then the last one? X minus 6, perfect. So dealing with that middle x is going to be the easiest. I would actually go ahead and deal with it first. I would distribute it to one of my 2 binomials. It doesn't matter which one. I just went ahead and distributed it to my second one. Got x squared minus 6x. And then I have to FOIL my result with my original x plus 3. So I probably would not do a box. I'd probably just do rainbows. I have 2 binomials multiplying. So that one times that one is x cubed. This one times this one is negative 6x squared. We have positive 3x squared and a negative 18x. And that's your final. That should be the polynomial that gives you the 3 answers from up above. Yep.
So every time these 3 polynomials, if there's an x in a parentheses without any other number, it would be 0 automatically, right?
Right. The solution to the binomial will be 0.
Okay.
Yep. For our next one, we get to use that conjugates rule that we learned about at the beginning. We've got negative 1, 2, and negative 3i. I'll go ahead and set up my 3 binomials. Okay, what would my first binomial be? Lexi?
X plus 1.
Yep, go ahead, you can do the other 2.
X minus 2 and x plus 3i.
Good. Now, the conjugate rule says if I have an imaginary solution or a radical solution, the conjugate of that solution is also a solution. So when Lexi said x plus 3i, I'm going to add x minus 3i on my list. There's actually 4, 2 real numbers and 2 imaginary numbers. Now, to save you some time, we're not going to make you FOIL this whole entire thing the whole entire way out. We're just going to make you FOIL so that we have all real numbers. So really, these 2, these are all real numbers, so these are fine. So I'm just going to leave my x plus 1 and my x minus 2. But I'm going to have to do a little bit of work here because I've got some imaginaries. Do you remember anything from chapter 1 about FOILing out conjugates?
Oh.
Yeah?
So once you FOIL them and you get like I squared, and then it's negative. Then you make it negative.
You're going to replace your I squared to the negative 1. That's absolutely something you need to know. But there's something even better to remember about FOILing out. Do you remember? You don't have to do the whole entire FOIL. So you don't have to do this guy, this guy, this guy, and this guy, because the inners and outers would have 0. So you only have to do your x times your x, get x squared. And your 3i times your negative 3i, which is negative 9i squared. So I kind of like that Andrew remembers that when I get that I squared, whoop, 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 a little alarm goes off. We can erase the I squared. It has the value of a negative 1, so it turns this 9 to a positive. And you can actually just stop right here. If you really feel like you want to be scholarly, you're allowed to FOIL it out, but I'm not going to force you to. Okay? What? What do you say, Nick? I'm mumbling again.
So how would you just stop right there?
Yeah, sure, 'cause we have all real numbers.
Well,
If you want to be scholarly, FOIL your little heart out, but I'm not going to make you. Yeah.
So instead of writing out the conjugate, could you just do x plus or minus 3i?
I mean, you could, but you'd have to be smart enough to get into here. I mean, so I'd probably just write it out. All right, I think we're going to do one more. This is the one with a radical. So we have 3 solutions right now. They were kind of nice. Look, they included both the positive radical 5 and negative radical 5, so we don't need to pull a conjugates theorem and remember any of them on our own. Let's get all 3 of them written out. We'll have x minus 4. We'll have x plus radical 5. We'll have x minus radical 5. We're only going to make you FOIL these ones out so that you're left with rational numbers. You don't have any like radical 5s. So it's going to be real similar. I'm going to put brackets around these 2 because these are the ones I'm going to FOIL. But since they are conjugates, you can save time and only do your first and your last. So what is x times x? And this one's tricky. What is a positive radical 5 times a negative radical 5? Negative radical 25. And then you're definitely allowed to take the square root of 25, so what would that be? X
5.
squared minus 5. And you can stop there, unless, I mean, if you want to FOIL it all out, go for it, but we're allowing you to stop when you get to the rational numbers. All right, so for the homework tonight, I'm going to give you a paper, but the instructions are, you're doing 9 to 16. 11 to 13, we do want you to FOIL them all the way out. So have fun FOILing. But then on 14 to 16, you can do what we just did in our last two examples, where you FOIL until your imaginaries or your radicals are gone, and then you can just kind of walk away, save some time. Okay? Sound good?